Hi everybody, welcome to week 4 of the class. This week we are doing we're still using descriptive statistics, and this week we are exploring measures of center and also devices or statistical tools to help us compare data. So in this first video we are going to specifically talk about applying measures of center. So when we look at the 3 basic parts of this week's material, we're going to be number 1 in this first video talking about measures of center, and our objective for this week is that by the end of the week we're going to develop the ability to measure the center of a data by finding the mean, median, mode, and also the mid-range. We're also going to be able to determine whether an outlier, we're going to learn how to identify identify an outlier and determine whether it has a substantial effect on the mean or median. In video 2, we're going to talk about measures of variation. So we talked about this a little bit before. We're going to start practicing some of these. We're going to develop an ability to measure variation in a sample data rather. We're going to find values of range, variance, and standard deviation. And then we're also going to develop an ability to interpret values of standard deviation. We're going to use something called the range rule of thumb to determine whether a particular value in the data set is significantly low or significantly high. Okay. And then the last video, or not the last video, but the last topic is measuring relative standing and also looking at box plots. This is where we are comparing data. So we're going to develop the ability to compute z-scores and use the results to determine whether a given value in the data set is significantly high or low using z-scores. We're going to learn about percentiles. We're going to be able to identify percentiles and also quartiles of a data set. And we're also going to learn about box plots. We're going to learn how to make a box plot, and we're also going to be able to make what's called a modified box plot with once we identify our outliers. Okay? And then finally, we're going to develop the ability to interpret values of standard deviation by applying the range rule of thumb to determine whether a particular value in our box plot or our measures of relative standing is significantly high or low. Okay. So this video is all about measures of center or central tendency. Now, we previously learned about 3 important measures of central tendency. We learned about the arithmetic mean, the median, and the mode. Okay? And we've practiced how to calculate mean, median, and mode. With the calculation of mean, it's a pretty standard, simple thing. If we add up all the values in our data set, and we then divide that number by the number of values in our data set. Okay? And that gives us our mean. The median, we put all of the data in order of magnitude, and then we pick the center data, the data point that's in the very center, to represent our middle or our median. And if it's an odd number of values, it's pretty simple. We just pick the number that divides the 2 in half, and that's our median. But if it's an even number of values, we have to pick the middle 2 values and then add them together and divide by 2, and that gives us our median. And the mode is the most common value that comes up. Okay? So the value that repeats itself the most is our mode, and that is our measure of center for mode. So each of these measures of center that we've learned have their own unique properties. Okay? Properties of the mean, some of them are very good and some of them are less desirable. The mean is very unique. For any given data set, there's only one mean. The mean is very simple. It's easy to understood, and it's easy to compute. And finally, one major drawback of the mean is that it's very vulnerable to distortion by extreme values. Okay? Every value in the data set gets calculated into the mean. So any extreme value, any extremely low value or extremely high value is going to affect this mean, and it's going to tend to distort the center of the data. Okay? If you have a very, very low value, you know, one or two very low values, it's going to pull the mean closer to that value. If you have a couple of very high values, it's going to pull the mean towards that high value. Okay? And so in this way, the mean is not quote-unquote resistant to distortion by extreme values. That idea of these measures of center being resistant, that means that to be resistant means that this measure of center is not vulnerable to distortion by extreme values, and the mean is not resistant. The median also is unique. There's only one median in a given data set. It is also very simple. Like the mean, it's very easy to determine. And one advantage of the median over the mean is that it's not drastically affected by extreme values. Okay? Since we're literally looking at the center of the value of the data set, once we put the values in magnitude, order of magnitude, because we're just looking at the middle values, it's not going to be distorted by an extremely low or extremely high value. Okay? So the median is resistant to extreme values. And then the mode also has its own unique properties. One of the best advantages of mode is that we can actually find the mode of qualitative or categorical data. So a data set does not need to be numeric in order to have a mode. Also, a data set can have more than one mode. It can have no mode, or it can have one mode. Okay? So there's a variety of possibilities. Okay? So for example, in a data set, if we have two values that occur with the greatest frequency, okay? If we have 10 values and there's two values that occur 4 times, right? Then we have two modes. And when there are two modes in a data set, we describe that data set as being bimodal. Now, if you have a data set and there are multiple values, more than 2 values, that happen with the greatest frequency and the same greatest frequency, then each is going to be a mode. And that data set we call multimodal. There's more than 2 modes. Okay? And if you have a data set where there's no repeated values, right? Every single value or every single data point is unique, then that's a data set that has no mode. So it's very possible for a data set to have no mode at all. Now there is another measure of center that we have not talked about yet, and that is the mid-range. And the mid-range is not used a lot, but it's helpful to understand and know that it exists. The mid-range of a data set is a kind of measure of center that is the value midway between the maximum and the minimum value of a data set. Okay. And it's found by adding the maximum data to the minimum data and dividing by 2. Okay. So the mid-range of a data set is the maximum data plus the minimum data divided by 2. So it's really an average. It's an average of the lowest data set and the highest data, the lowest data point and the highest data point. Okay. So the mid-range could sound a little like the median because we're looking at the midway between these two extreme values, but it's calculated very differently from the median. So you're going to get a number that is potentially different from median. And because the mid-range only uses the maximum and minimum values, it's going to be very sensitive to those extremes. So the mid-range is not only not resistant, it's actually very vulnerable to distortion by those extremes. Now, in practice, the mid-range is really very rarely used, but it does have three good qualities that are worth learning about. Number one, the mid-range is very easy to compute. Second, the mid-range really helps reinforce the very important point that there are several ways of defining the center of a data. And lastly, the value of the mid-range is sometimes used incorrectly for the median. Okay, so sometimes people think that they're calculating the median, and what they're really doing is calculating the mid-range. So confusion really can be eliminated if we very clearly define mid-range as we are talking about median. Now, so now we've got several ways of estimating the middle of a data set, right? We've got the mean, we've got the median, the mode, and the mid-range. Now, sometimes you want to calculate the mean, but you don't have access to the raw data. So one variation of a method to calculate the mean of a sample is to use the information that's provided in a frequency distribution table. So if we are looking at the frequency distribution table, but we don't have access to the original data set, we can still estimate a mean. But one thing that's important is that this method of calculating the mean from the frequency distribution is not an exact way of measuring the mean. It really just gives us an estimation of the mean, okay? or an approximation with the mean. But it can be very useful when you're working with summarized data rather than raw data. So the way to do this, the way to calculate the mean from just a frequency distribution, is to take the frequencies. So usually in the frequency distribution, we're given the frequencies and the data and the class intervals, right? So we take the frequencies and multiply by the midpoint of each of the class intervals. So we take the frequency and the midpoint and we multiply that together. And then we add up all of those values and divide by the sum of the frequencies. So let's look at an example of this so that we can see what we're talking about. So we're given a frequency distribution table where we have our class intervals. So this is pulse rate of a group of males. In our textbook, there's this big data set in the back of the book called the body data, right? And so this is coming from that body data, so pulse rates of males. So we have 1, 2, 3, 4, 5 class intervals. We have the frequency of each of those class intervals. And then we also calculate, we have to calculate the midpoint of each class interval. So the first class interval, the midpoint is 47. 47 is right in the middle of 40 and 54. And remember, calculating the midpoint, we add those two numbers and we divide by 2. So 40 plus 54 divided by 2 gives us 47. The midpoint for interval 2 is 55 plus 69 divided by 2, that's 62. For the third class interval, the midpoint is 77. For the fourth class interval, the midpoint is 92. And for the fifth class interval, the midpoint is 107. Okay. So if we want to get the average from this this frequency distribution table, what we're going to do is multiply the frequency times the midpoint. Okay. This is the number of times that this midpoint occurs in the data set. Okay. So 15 times 47 is 705. 63, second class interval, there was 63 data points that landed in between those two values. 63 times 62 is 3,906. Okay. We've got the third class interval. The multiply 62 times 77, you get 4,774. The fourth class interval frequency is 11. The midpoint is 92. 11 times 92 is 1,012. And the last class interval, there were two data points that were between 100 and 114. So 2 times 107 midpoint is 214. Then we add up all of those values and we get 10,611. We add up all the frequencies. 15 plus 63 plus 62 plus 11 plus 2 gives us 153. And then we divide 10,611 by 153. That gives us 69. So the average pulse rate of males in our sample is approximately 69 beats per minute. Okay. Now the reason why this average is an approximation and not an actual mean of the raw data is because we are assuming that in each of these class intervals, right, we are basically, instead of using the raw data of all of these 15, for example, that have a pulse rate between 40 and 54, all of those numbers are likely different. Instead of adding those numbers together, what we're doing is we're assuming that all 15 have a pulse rate that is right in the middle of the class interval, 47. Okay. So because we're using the midpoints of the class interval rather than the raw data to calculate our mean is an estimation. Okay. But it's a handy way of estimating the mean when we don't have access to the raw data. We only have access to the summarized data. Now, another way of calculating mean is calculating what's called a weighted mean. Now, sometimes the data points in our data set are not all the same in terms of importance. Okay? Sometimes some data should have a larger portion of the mean than some other data points. Okay? For example, if you're taking an open class, one of the open classes, and your quiz grades are worth 25% of your grade, homework is worth 25% of your grade, and the two exams are worth 50% of your grades. Each of those averages, right, each of those quiz scores, homework, and exams carry a different weight on your overall exam grade. Overall course grade. Okay. And so in that situation, we're going to calculate what's called a weighted mean. And to calculate a weighted mean, we're going to take our data point, multiply by the weight that data point has in the data set. We're going to add up all of those values and divide by the sum of all of the weights. So let's look at an example of this. So let's say Sarah is taking biostatistics, and she wants to know what her average grade is right after she's taken the first exam. Okay? So we're halfway through the class. She's taken the midterm. She wants to know what is her grade right now, halfway through the class. Okay? So her homework average at week 5 is an 80%. Her quiz average at the week 5 is a 90%. And she earned an 88% on the midterm. Okay. So if we want to calculate her average in the class right now, right? Remember, homework was worth 25% of the grade. Quizzes are worth 25% of the grade, and exams are worth 50% of the grade. So we take her average of 80 on her homework, multiply by 25%. Take her average of 90 on the quizzes, multiply by 25%. And we take her midterm grade and multiply by 50%. Okay, that represents all of the exams. And then we add those numbers together. So for her homework, 80 times 25 is 2,000. For her quizzes, 90 times 25 is 2,250. And for her exam grade, 88 times 50 is 4,400. And the total of that is 8,650. Now we have to divide by the sum of all the weights. So 8,650 divided by 25 plus 25 plus 50 is 100%. So 8,650 divided by 100 is 86.5. So Sarah's average grade in the class right after the midterm is an 86.5. Okay. Now, for the rest of the class, right, she's going to take more she's going to do more homeworks, she's going to do more quizzes, take the final exam. So her grade might change, but at that midpoint, that's what her grade is, based on this weighted mean.